is something that, or like something that would show up on the free response, right? Yes?
I still don't really understand why on the part of the graph on the right side, why it goes over the x-axis. Could you explain that part?
I don't know how to explain it in a way that would make more sense to you.
Okay.
Saying that when there's one vertical asymptote, you'll never run into this situation.
Okay.
So it's kind of like the vertical asymptote and the horizontal asymptote are equally important.
Okay.
But when there are two vertical asymptotes in a graph, the graph does this really weird thing and actually crosses the horizontal asymptote,
Okay.
which you kind of see is going to happen anyway because you end up with an x-intercept somewhere where you thought the function wasn't even defined.
Right.
So don't get too caught up in it. That's not going to make or break you on this final. Okay? How are we doing? Good? All right. All right, so we didn't have a chance to do a problem on Wednesday that the period 1 class did have time to do, which was talking about chapter 7. And if you look at your free response, you will see that your free response did indeed have on it, please put this away, lots of word problems. So if I'm going to give you something from this unit, there's probably a pretty good likelihood that it is a word problem. Meaning it starts as a table of values, which you then examine the pattern of. And last class we did talk about the various patterns that you would see. And so let's presume that you got through the problem. You obviously realized that this one had been an exponential function, which means we had to have seen the pattern of add, multiply. And we then utilized our first point and our last point, and we got to this moment where most of you tell me the hard part are the questions that come after. So I wanted to go over that with you. So if you went to all the steps and you were able to find your equation, and x happened to stand for minutes, and y happened to stand for temperature, if you were asked the question, what is the temperature after 10 minutes, that means that you need to find, Henry, which variable?
Why?
When what?
X is 10.
X is 10. Which means you would plug in
10.
10 for X. And if I say numerically, then I'm allowing you to use your calculator and the table. But if I say algebraically, that means I want to see you crunch the numbers. So you would raise 0.9 to the 10th power. It's always a good idea to show some work along the way. but it's not a good idea to round anything, bless you, until you get to the end. And you know that if I don't tell you how to round, you should round to the hundredths. So Henry, what would the temperature be after 10 minutes?
35.67 degrees.
35.67 degrees. Yes.
Would you round to the tenths just because that's what's in the problem, or you should always round down just by default?
Hopefully I'll tell you what I want you to round it to, right? Most of this year, when you guys didn't round it the way I asked you to, I didn't penalize you. Most of the time. I just put a line up to where it said how you were supposed to round. Okay? So don't get too caught up in that. I hope there's not anybody who thinks rounding things to the nearest whole number is appropriate in math. That I wanted to break you up if you weren't already broken of it in algebra.
Thank you.
It's the second question, though, that some of you find harder, and that is, if the temperature is 54.366, how many minutes have passed? Now it means, Henry, to find
X.
x when y is 54.366. So you go back to your equation and you plug in 54.366 for y. And the first thing you do on your calculator, Henry, is
Divide both sides by 102.3.
divide both sides by 102.3. And you get 0.53 ... equals 0.9 to the x. And at this point, to get out of this problem, it requires using, Henry,
Change it. You should change the form.
so using
Logs.
logs. So when you change the form, the base is what doesn't change. So it's log base 0.9 of 0.53 ... because there was no need to round it, it's just sitting in your calculator. And then you may use the calculator to do change of base formula, or you can do it yourself. So this 0.53 is in your calculator, and so you do log of my answer divided by log of 0.9, and your calculator will tell you that x is indeed 6. It's actually 6.00007, and that's only because our calculator actually rounded this answer at some point, but that's not significant enough to matter. So how many minutes have passed? The answer is 6 minutes have passed. So we now have gone over main topics in all 5 of the units, and we are now going to shift to multiple choice. And the first multiple choice question, or multiple choice test, that we're going to look at is the most recent one, which was chapter 15. I'm gonna go over all the questions that were on this test. And if you have the same experience that period 1 did, you're gonna tell me in a few minutes that that was very valuable to you. So, you are more than welcome to copy down anything you would like right now as we go over the multiple choice. And we begin with question number 1. Question number 1 says, find the vertical, horizontal, and slant asymptotes. So first off, if you understand the way this unit works, it is completely impossible to have both a horizontal and slant asymptote. So that's not the answer. Then if you look at the function, you do see that the degree of the numerator is 1 more than the denominator. So you do know that you have a slant asymptote. Now the answer's either C or D. You actually don't even need to find the slant asymptote, because if you look at the vertical asymptotes, one answer choice says they're 5 and -1, and the other one says they're -5 and +1. So long division isn't even required here. All you have to do is factor x squared minus 4x minus 5, getting Henry
Sorry, x minus 1, x minus, sorry, yeah, x minus, sorry, x plus 5, x minus 5, x plus 1, sorry.
Henry just
Yeah, it was, yeah.
Henry just showed you what not to do on the day of your test. Stay focused. And so now the question is, Henry, is there a vertical asymptote at 5 or -5?
5.
5. So the correct answer to this problem is C. It doesn't even matter what the slant asymptote is, because we already found the right answer. And when you took this test, 74% of you got this answer right. And those that didn't get the answer right, what am I looking at here?
Chapter 15.
Oh, I'm looking at the wrong answer thing. Sorry. 15. Alright. And, sorry, 97% of you got this one right. I thought that was too low. 97% of you got this one right. There were 2 people that chose A as the answer. So they went about finding the slant asymptote, obviously, right? And then, for some reason, they thought there was a horizontal asymptote. Wait. That makes no sense. So, 97% of you got this one right. Good job. Moving on to number 2. I remember some of you coming up to me and talking to me about these kinds of questions. And you said, I don't get it. How am I supposed to know this stuff? This is about seeing the degree of the exponent of your function. And when you see that the degree of your function is 8, can everyone see that's an 8?
There we go.
If you can see that the degree of the function is 8, you know it has an even degree. That means either both ends are going up or both ends are going down. And because of the negative leading coefficient, both ends are going down. So you're looking for an answer that has negative infinity for both. And the correct answer is D. Moving on to number 3. Question number 3 asks what kind of discontinuities we see in this function. Now, just by knowing that this unit is about rational functions having discontinuities, and you see a rational function, you know the answer is not A, no discontinuities. It requires you to factor the denominator. When you factor the denominator, you get
X minus 3x plus 1.
x minus 3x plus 1, meaning something is going to cancel and give you a whole, and a whole is called a point discontinuity. So if you know that this has point, also known as removable discontinuity, you now know the answer is either B or D. Then you should know that any factor left in the denominator is a vertical asymptote, which is called an infinite discontinuity, and that's why the correct answer is D, and 86% of you got it right. What is jump discontinuity? Piecewise function that jumps. That was going to be your question, right, Henry?
Yeah.
No, actually, it was this Henry.
Oh, sorry.
Henry's like, oh, she's talking to me. All right. This one's not terribly easy to see. It didn't come out very dark on some of these graphs. But it's asking you for a 5th degree polynomial. 5 is an odd number. Odd means opposite end behavior. Just knowing opposite end behavior tells you it's not C or D, because C has both ends up and D has both ends down, and they're the same. Then it says a positive leading coefficient, which means it's the right side that should be going up. Therefore, the answer is A, and 88% of you got this right. How many of you are benefiting already from going over this? Moving on to number 5. Number 5 asks you to turn these into partial fractions. Since this was a new idea this year, I would say something like this would very much show up on the final. It's a topic we are taking out next year because of all the things we have to put in. The way this works is you take the denominator and you factor it. Factoring it isn't such a big deal because you can also look at the answer choices. And this is called the Heaviside method, named after Oliver Heaviside, remember? And the way it works is, if you want to figure out what goes over the x plus 3, you cover up the x plus 3. And the value of x you covered up is when x is negative 3. And then you plug in negative 3 where x is, and you get negative 15 plus 1, or negative 14, over negative 3 minus 4, or negative 7, and you get 2. And now you know the correct answer is C, and you don't even have to finish the problem. If you blanked on this problem and forgot how to do it, you could always go backwards and add the fractions together yourself. But hopefully you won't forget. And 79% of you got this one right at the time of the test. Number 6. When we look at number 6, we know that we're looking at a piecewise function. And a piecewise function, if it has any discontinuities, will have jump discontinuity. However, a piecewise function also could be continuous, depending upon if at the point where they're both having the same value, which in this case is -2. If when you plug in -2, you get the same y value in both, then the function is actually continuous. If when you plug in the -2, you get a different answer for y in each case, it means the graph jumps. So if we plug in -2 right there, we get -5. So at -5, at -2, -5, we have a closed circle. And if you plug in -2 in the other one, you get -7. And so at -7, you have an open circle. So indeed, the graph does jump. How many of you think that might have been one you didn't do right? Yeah, that's the first bad scoring problem. 59% of you decided that this one had jump discontinuity, but there were 18% of you that used the answer A. I'm not sure why. All right. Do you think that's mainly what this unit's going to be about? All the different types of discontinuities and limits, right? Okay. Here's another question that we didn't score very well on. And this one I can remember for sure somebody coming up to me and asking me about. It gives you a rational function, and it asks you which of the following determines the horizontal asymptotes. Now, at the time when people were taking the test, they looked at this problem, and they said that the horizontal asymptote was 1. And then they were looking at the limits, and they expected to see the limit as x approaches 1. No, 1 is the answer to the limit. Horizontal asymptotes are the functions and behavior. So what kind of limit do you do for n behavior? Infinity. What's the only answer choice that has infinity? C. That's the answer. It's C. Any questions? Yes.
Can you, just repeat what you just said?
Okay. Horizontal asymptotes are your end behavior. End behavior is limits as x approaches positive and negative infinity. The answers to end behavior are infinity when there's a slant asymptote and a number when there's a horizontal asymptote. This is asking you which one determines the horizontal asymptote. What kind of limit do you do? the kind of limit you do when you're finding your horizontal asymptote is a limit as x approaches positive or negative infinity. This problem, actually what it says there is positive and negative infinity, but it's really small. I can't see it too well. Makes me nervous. It's too small to see. Okay, so what kind of limit determines a horizontal asymptote? A limit at x approaching positive and negative infinity. Sam, are you on your phone? Okay, please stop looking down. You're distracting. All right, question number 8. I want you to pay close attention to question number 8. Because I have realized by how you guys answered these questions on, 8. On number 7, only 52% of you got this one right. And on number 8, it was 53. So these 3, 6, 7, and 8 have been low. When you look at number 8, and it asks you to do a limit at a number, put this in your notes right now. Anytime you have a rational function and you're doing a limit at a number, factor it first. If you think about your standard, what was the very first thing you did to the function? You factored it.
Can you repeat that again?
Anytime you're asked to do a limit on a rational function, factor it first. If you factor this one in the numerator, you get x plus 1, x minus 1. And then it's over x minus 1. And it cancels. So now, all you're doing is the limit as x approaches 1 of x plus 1. Which now means plug in 1. And the answer is 2. Here's what's happening that many of you are doing wrong. You're plugging the 1 in at the beginning. But then you're showing a confusion in your understanding of numbers. If I plug in 1 right here, what happens in the denominator? 0. Anything divided by 0 is undefined. Is undefined even an answer choice? No. When you took this test, 53% of you got 2, but 41% of you chose 0. So you are worrying me because you're forgetting that when you get 0 in the denominator, something divided by 0 is not 0. And in a way, it brings up the very first unit of Math Analysis A, when we were learning our unit circle. And we talked about how 1 divided by 0 is undefined, but 0 divided by 1 is 0. And you got that straight. Every once in a while, I have math analysis students who say that this answer is 0 and this answer is undefined. And that means they have poor number sense. If you get 0 in the denominator, it doesn't matter what you get in the numerator. It's undefined. And undefined and 0 are not the same thing. Who had something cleared up? Good. Questions? So, 53% of you got it right and 41% of you chose 0. That's worrying. Number 9, without graphing, choose the function for when x approaches negative infinity, you get positive infinity. They're saying which one of these graphs has the left side of the graph going up. They're saying which one of these graphs has the left side of the graph going up. That's either an even function with a positive leading coefficient, or it's an odd function with a negative leading coefficient. For this one, it's cubic, positive leading coefficient. The right side would go up, the left side would go down. It's not this one. This one is an odd function with a negative leading coefficient, and this is the correct answer, because a reflection means that the right side goes down and the left side goes up. Both of these are the same, aren't they? They're even degrees and negative leading coefficients. Can they both be the right answer? That means they're both not the right answer. The correct answer is B. 81% of you got it right. Yes?
So how do you know that, like, what it's asking is it goes up when it goes down?
Because they're saying that the limit as x approaches negative infinity.
Oh, so that's the one.
So they're saying when you look to the left of the graph's going up. Okay, number 10, describe the graph. This problem was actually, of all of them, the lowest scoring question on the test. And this one is asking you what type of discontinuity it has. Now, the fact that it's rational tells you that it has a discontinuity. So, answer choice D is incorrect. A lot of you forgot. What did we just say a second ago about rational functions and doing things always factor? Many of you don't remember that x cubed plus 27 is the sum of cubes. It factors to a binomial times a trinomial. It's x being cubed plus 3 being cubed. And even if you don't remember exactly how it factors, the binomial is x plus 3. And if you have an x plus 3 over an x plus 3, the x plus 3 is going to cancel, making the discontinuity a point removable whole. The correct answer is C. 47% of you chose it. 32% of you, 34% of you chose A. You saw this one as an infinite discontinuity. You thought that was a vertical asymptote. You did not think about the idea that this might factor. How many of you are pretty sure that you're one of the people I'm talking about right now? Number 11 is a complete deja vu of what we were talking about earlier. Before you plug in 4, factor it. So when you factor x squared minus 9x plus 20, you get x minus 4, x minus 5. And now the x minus 4's cancel. So to find the limit as x approaches 4, you just plug in 4. 4 minus 5 is
-1.
-1. That's why the correct answer is B. 64% of you chose B, but 32% of you chose A, and you made the same mistake. You got 0 in the denominator, and you said that when you divide by 0, you get 0. Stop doing that. Okay? Moving on to number 12. Which of the following shows the graph here? This one has a horizontal asymptote at 1. That means that it's probably an x squared over an x squared. That being the case, the answer can't be A. In A, there would be a slant asymptote, not a horizontal. The answer could be B, it could be C. I doubt that it's D because the graph also has a hole. So something canceled. To figure out if it's B or C, you pretty much would plug in 1. So if you, the point that you want to have in the function is that when x is 1, y is 2. So you try both of these and you figure out which one's correct, and you end up with B being the correct answer, not C. And 71% of you got that one right. But 22% of you chose A. I don't know why. Well, yeah, I know why. A looked okay, and you chose A, and you never even looked at the other answer choices. Number 13. Which of the following represents this function? By knowing that the degree of the numerator is bigger than the denominator, then you know that this function has a slant asymptote. C's out.
Nikki, move it up.
Then you have to kind of figure out whether your slant asymptote is a positive sloping line with a negative y-intercept, a positive sloping line with a positive y-intercept, or if your slant asymptote is a negative sloping line. And the way that you find your slant asymptote is using long division. And so you would start doing long division here. And you know that you're going to get a 2x.
Negative X.
And now you get a negative x. So you get that your slant asymptote is going to be y equals 2x minus 1. At first you got that it's a positive slope, and the fact it was a positive slope eliminated d. And then when you saw that it was 2x minus 1, you saw that it needs to have a negative y-intercept and not a positive y-intercept. And that's why the answer was A. 63% of you chose A. 29% of you chose B. Questions? All right. Couple more problems and then we'll look at the chapter 7 one, at least at the ones that you guys missed the most. State the domain restrictions. This problem was ridiculously easy. If you factor the denominator, you'll find out that the domain restrictions are that x can't equal negative 1 or 3. These were Common Core questions with more than one answer. There are 3 zeros of the function. You would do synthetic division. I would do synthetic division on either the 3 or the negative 2. You'll find out that the first 3 answer choices work. Question number 16. We have played around with this problem for years, with changing the wording. And we always have different opinions as to what's the best kind of wording to use. And many of you came up to me and were wanting me to translate for you what it meant by 2 different and 3 different real zeros. The fact that there are only 2 x-intercepts means there's only 2 different real zeros. You can tell that this function has an odd degree because one end goes up and the other down. You could even watch it increase, decrease, increase, decrease, and increase, and know it's quintic. So it's degree 5. Does it have 5 local extreme values? No. That's like local minimums, turning points. It only has 1, 2, 3, 4. E's not the right answer. Does it have 2 complex zeros? Yes. Anytime the graph turns in the air, it has complex solutions. Does it have 1 double zero? It sure does, right there. So we know the answer is C and D. And now it came down to what's right, A or B. And what is right? A. It has 2 different real zeros, not 3 different. If it had 3 different, there would be 3 times it crossed the x-axis. Once again, do I understand that the wording is a little tricky and confusing? And is it not the best problem? Yes, I agree. But 3 of you want to say something about it. Yes.
I just want to make sure. So when a function has a double zero, that's still considered a real zero, right?
Mm-hmm.
Okay. I just want to make sure.
Real zeros cross the x-axis. Imaginaries turn in the air.
Okay.
You said it, but complex zeros are.
When it turns in the air, it has imaginary zeros.
I was gonna try to clarify the language, because if.
No, I don't care.
It'll help, I think.
No.
Okay.
Better to spend time working over here.
Alright.
Although I appreciate it.
Whatever.
Yes. With chapter 7, and we certainly can come back to multiple choice on Friday, our all classes meet day, if you want. Or we can just spend time on that day with people, asking me what do I need to get in the class to get whatever grade. It's up to you. But I want to go over the ones that you missed the most. So if I were to pick the worst problem here, it's number 11. A lot of you thought that this test was hard. Question number 11, only 42% of you got right. It reads e to the 2 natural log of 5 minus log base 2 of 8. It should not be hard for you to know that log base 2 of 8 is 3. Does everybody know that?
Yeah.
Okay. Where it does get a little hard is this one. When you see a 2 in front of natural log, it means it's 5's exponent. So this is really e to the natural log of 5 squared. Now, hopefully, you have some sort of recollection that e and natural log are each other's inverse, and they essentially cancel. 5 squared is 25, and 25 minus 23 is 22. And so the correct answer was D. 42% of you got that right. 29% of you chose C. And that means that when you saw the 2 in front, you interpreted it as 2 times 5, or 10. And 10 minus 3 is 7. At this moment in the other period, a kid raised their hand and said, is this considered an advanced question? And my answer is no, because it's a review from Algebra 2. Questions? Okay, I'm going to try and get a couple more in. Another question that we scored low on collectively is number 14. And this one had you looking at 4 graphs and deciding which one of them was that equation. You can tell by looking at all these graphs that they're graphs of exponential growth. And your normal graph for exponential growth looks like that. If you think back to transformations, this -1 right here means the whole graph moved down 1 unit. So where there used to be a horizontal asymptote at y equals 0 in this function, it went down 1 unit. And now there's a horizontal asymptote of y equals -1. Are you with me?
Mhm.
Which one of these is the correct answer? D. Many of you chose C. You forgot that that's a vertical translation. Okay. Another one that you guys scored low on was number 10. Number 10 just said, which statement is correct for this function? And the function is y equals 2x squared plus x. Well, y equals 2x squared plus x is a parabola. And it's a parabola opening up. And it's even a parabola opening up with the origin as its vertex. So, it is not the range that is all real numbers. It's the domain. The function is increasing at one spot, but it is also decreasing. So the function decreases and then increases. And if you look at B and C, one says concave up and one says concave down, and you kind of can get an idea that it's one of those, right? Is that concave up or down? Up. So the correct answer is C. Number 5. This is the only other one that we scored real low on. And I will tell you the same thing that I told my period 1 kids, and that is that I did see one just like this on your test. This one is asking you for the domain and the range of natural log. You know that this is an exponential function and this is a logarithmic function. You know that an exponential function has a domain of all real numbers and a range of y is greater than 0. And you know that a logarithmic function is the reverse. So it's the domain that is x is greater than 0, and it is the range that is all real numbers. Our function had a horizontal translation 2 units to the
Right.
right. That means,
I thought we were doing the
Yeah, we're doing the one.
we're doing the
Sorry.
one.
I realize that. So we know that if ours is logarithmic, for sure its range is all real numbers. Okay? So if you look at the answer choices, it's not B. Now if you look at the domain, remember last year in Algebra 2 you can't take log of a negative. You also can't take log of 0. So the parent function of log x or natural log x, y equals, has a domain that x is greater than 0. This one had a horizontal translation 1 unit right. That means its domain when 1 unit right. So its domain is x is greater than 1. What does that make the correct answer then?
Okay.
I hope you benefited from the review today. The next time I see you is on Wednesday, the day of your free response. I know you're going to come prepared, and you're going to have your calculator